Cinque. Today we're going to be looking at diagrams, and this is from the Copeland text. So I'm getting this work from Copeland, which is pages 50 to 51. We're going to discuss the idea of space and free body diagrams. So I shall write that up on the board. Free body diagrams, and you'll sometimes see the free body diagram with the acronym FBD. Okay, so we'll write a little bit of an introduction. Basically, a space diagram is a picture of a physical situation, usually with superfluous detail to actually show you what's going on. And then the free body diagram is where you take away a lot of the superfluous detail to really make it clear angles and forces, etc., that's being applied to a body in a mechanical sense. So that's the two different types of diagrams. So let's just write up these definitions. Space diagrams, if not pictures of Mars, are an illustration, a fancy way of saying a picture, of a situation in a question. So you might get these in a question in an exam. Situation, so we'll put a capital letter here to make a bit more sense. In a question, often the extra detail in a space diagram can create confusion. This is why we make a free body diagram, or FBD, to solve problems. And we're given a really nice illustration of the difference between those types of diagrams. You know, you might have a picture of a crane, and it's lifting a weight. And you're asked to create a free body diagram for that type of situation. So, you know, you don't need all of these sort of extra details of the crane. The crane boom could just be represented by an arm with a fixed point. That could be 30 degrees. And this could be a force acting down of 1,000 times 10, which is 10,000 newtons. Okay, so this would be your free body diagram, and this would be your space diagram. So your free body diagram is just a very pared down illustration of the situation. So the one that they have in the book's a nice one. It tells the story probably better than that one I just did. So, and in that one we've got a river with some water happening. And we have a log. You can see that. You can't really tell I went to art school, it's quite sad. Okay, and that's our log. And then we will have like a young lady running across, and we'll have a little child running across, and then we'll have me crossing the river. And that's our space diagram. Obviously they might give you other information like the weights of these people. So we might have like 30 kgs, 15 kgs, 110 kgs, okay? That's our space diagram, and if you were asked to create a free body diagram for this, it'd be very, very simple. You would just have a fixed support at either end. You might actually be given a distance here as well. 50 meters. Okay, so space diagrams give us a lot of information already, but our FBD will remove a lot of superfluous details. So we've got basically some fixed supports for the log. We know that our distance is 50 meters, and then we know our weights are this one here. We'll do the arrows. F1 equals 300 newtons, and then F2 equals 150 newtons because it's 15 kilograms, and this one's a much bigger arrow, and it would be 1100 newtons, F3. So you can see, if you look at, I've made it a little bit confusing, so pause the video and draw your space diagram, and from your space diagram you can see that, well, I'm hoping that you can see that the actual free body diagram of that situation is, we'll draw our arrows to scale to, sorry, that one's going to be shorter, this one's going to be longer. Let's neaten this up because this is a mess. Okay, I think we said it's 35, so we're going to go 350 newtons, F1. This one was F2 equals 150 newtons, and F3 equals 100 newtons. So that's your free body diagram. A lot simpler and a lot better for problem solving. So sometimes it helps to draw the actual situation first and then draw a free body diagram. Quite often if you're given a space diagram in an exam, which is the most likely scenario, you would then draw your free body diagram. And that is how to draw a free body diagram, and this is something that you're going to be asked to do in exams over and over again. When you do it, always do your diagram with distances and forces and whatnot involved, and always label it FBD to indicate to the examiner that you know what a free body diagram is. And like I said, page 50 and 51 of the text, if you want to have a look at it in the textbook. That is the difference between a space diagram and a free body diagram. Write the notes down, pause the video, do the diagrams, and make sure you remember the difference between the two types of diagrams.